Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P1454 indicates there is a range or performance problem with the fuel tank pressure FTP sensor in the EVAP, evaporative emission control system, essential for monitoring fuel vapor emissions. The affected components are the FTP sensor, located near the fuel tank, and the EVAP canister vent shut valve, which controls vapor release from the EVAP canister. A malfunction in these components can lead to increased emissions, resulting in a failed emissions test. The role of the FTP sensor is critical, as it detects the pressure changes inside the fuel tank, which helps in managing fuel vapor. If this sensor is faulty, it won't provide accurate readings required for the engine control module, ECM, to function correctly. Therefore, addressing this issue promptly ensures compliance with environmental regulations and optimal vehicle performance. DTC P1454 highlights an issue with the FTP sensor circuit in the EVAP system. The FTP sensor is crucial as it monitors the pressure and vacuum within the fuel tank, supplies data to the ECM, and helps prevent fuel vapor emissions. Typically, this sensor is situated near the fuel tank, allowing it to effectively gauge the conditions within the tank. If the FTP sensor malfunctions, it can lead to inefficiencies, including incorrect pressure readings, which can trigger the DTC. Another related code, P2422, signals an issue with the EVAP canister vent shut valve, which operates to control the release of fuel vapors. Understanding these components' functions provides insight into the troubleshooting process necessary for resolving the related DTCs. Potential causes for DTC P1454 include a faulty FTP sensor, which could be giving inaccurate readings due to internal electrical issues or physical damage. Blockages in the vent hoses connecting to both the FTP sensor and the EVAP canister can create pressure discrepancies, affecting sensor performance. Additionally, the EVAP canister vent shut valve might exhibit corrosion that prevents it from closing or opening properly, which would also elevate pressure readings. Consequently, this complex interaction among components means that thorough inspections are necessary. Each potential failure point must be investigated, as fixing one may not resolve the underlying issue if others are also impaired. Always ensure to check connections to rule out loose terminals that may lead to intermittent failures. Symptoms associated with DTC P1454 often include the illumination of the check engine light on the dashboard. This warning signals to the driver that the vehicle's onboard diagnostics have detected an issue affecting engine performance or emissions control. Increased emissions can also be a direct symptom, as malfunctions in the FTP sensor lead to inaccurate pressure readings that the engine's fuel management system cannot correctly interpret. Additionally, drivers may experience diminished fuel economy, which occurs when the vehicle attempts to compensate for incorrect fuel vapor readings. Other potential symptoms can include rough idling or stalling, especially if the engine struggles with air-fuel mixture adjustments influenced by the faulty sensor. Recognizing these symptoms early can lead to a more effective and efficient repair process. In the first step of troubleshooting DTC P1454, the technician must turn the vehicle to on mode, which activates the vehicle's electronic systems without starting the engine. Next, the DTC should be clear using the HDS, or Honda Diagnostics system, which resets the vehicle's onboard diagnostic capabilities. This is essential to ensure that any previous error codes do not interfere with current tests. After clearing the codes, the technician will need to check the pressure signal from the FTP sensor using the HDS to determine if current conditions fall within the specified thresholds. This involves ascertaining if the sensor is registering the appropriate values as per manufacturer specifications. If the parameters match the threshold, This indicates the sensor is likely functioning correctly, whereas discrepancies could point towards further issues requiring additional inspections or repairs. During the second troubleshooting step, it's imperative to remove the emergency fuel funnel from the fuel filler neck to ensure that the vehicle is in a proper state for evaluation. Next, the technician proceeds to turn the vehicle on mode again and clear the DTC using the HDS. Following this, the engine should be started and allowed to idle without load, which means placing continuous load on the engine should be avoided during this process. It's crucial to maintain the engine speed at approximately 3,000 RPM and monitor the EVAP PC duty, or purge control duty, which needs to be at 20% or more for at least 4 minutes. This step is necessary to identify if the DTC or related issues persist while the engine is idling, as this allows for better understanding of the EVAP system's operation under controlled conditions. In the third step, the vehicle is first turned off to ensure safety when working with components. After switching the vehicle to off mode, the DTC should be cleared once more using the HDS. The next crucial actions involve disconnecting the EVAP canister vent hose from the canister itself, which is essential to examine if any blockages are present. With the vehicle again switched to on mode, the technician needs to check the parameters of the FTP sensor using the HDS, as previously. This repeated measurement of pressure readings against thresholds will help verify if the vent hose is obstructed or if the FTP sensor itself is malfunctioning. If abnormalities are discovered, it indicates a blockage either in the vent hose or the EVAP system that requires resolution. In the fourth step, once again, the vehicle is turned to the off position before proceeding with the disconnection. The EVAP canister vent shut valve must be removed to check for any operational issues. After removing it, the 2-pin connector should be connected to the vent shut valve to facilitate further testing. The vehicle is then turned on, and a specific function test is performed using the HDS. This allows evaluation of the vent shut valve's operation by observing if it responds correctly. An ideal outcome would show that the valve operates without corrosion issues, indicating that it can open and close as necessary to regulate vapor flow. If the valve is found to be corroded or not functioning well, replacing it is essential to rectify the issue and restore proper EVAP system functionality. The fifth step focuses on the FTP sensor vent hose, starting with disconnecting the vent hose from the FTP sensor itself. Once disconnected, testing the sensor with the HDS is necessary to check pressure readings again. Matching these readings against the threshold will reveal if the vent hose is indeed blocked, contributing to the DTC code. If the pressure values align appropriately, it indicates that the hose is clear and the problem likely resides elsewhere in the system. Conversely, discovering a blockage means that the vent hose or adjacent components require cleaning or replacement to ensure proper ventilation and functionality of the EVAP system. This step highlights the importance of thorough visual inspections and functional tests throughout the troubleshooting process for effective diagnostics. In this final troubleshooting step, the procedure begins with turning off the vehicle once again to safely access critical components. After switching to off mode, the technician must remove the FTP sensor while leaving its electrical connector still attached. The vehicle is then turned to on again, enabling the technician to check the pressure readings via the HDS once more. This method allows for assessing whether the FTP sensor's port has any restrictions by observing if the sensor registers within defined thresholds. If the readings align properly, the next action is recognizing a potential internal blockage within the EVAP canister, which may necessitate replacing the canister itself. Alternatively, if the readings do not match, replacing the FTP sensor is recommended, as it indicates a failure in the sensor's functionality and accuracy, which is critical for maintaining vehicle emissions standards. After completing all the troubleshooting and necessary repairs, it's vital to perform a final verification to confirm that the issue has been rectified and that the vehicle is functioning as expected. Begin by reconnecting all the hoses and electrical connectors that were disturbed during previous inspections. After everything is reassembled, clear any existing diagnostic trouble codes via the HDS. Subsequently, the vehicle should be taken for a test drive under various operating conditions to gauge if the DTCs return. Monitoring the HDS during this drive is crucial to ensure that no new DTCs emerge, signaling underlying issues. Successful completion of this verification step assures that repairs are effective and that the vehicle complies with emissions regulations and operational standards. To maintain the integrity of the EVAP system and prevent the recurrence of DTC codes such as P1454, implementing a preventive maintenance strategy is key. Regularly inspecting the EVAP system for any signs of wear, damage, or blockage should be a standard procedure in vehicle upkeep. Connections, including electrical terminals and hoses, should be checked frequently to ensure they are secure and free from corrosion, which can lead to misreadings or failures. Additionally, if any components are showing signs of wear or are not performing optimally, timely replacement is essential. Early identification of potential issues allows for preventive solutions that can avert costly repairs and ensure that the vehicle operates efficiently and within emissions compliance standards. Regular upkeep not only enhances vehicle longevity, but also improves performance and reliability. In conclusion, DTC P1454 signifies a performance issue in the FTP sensor circuit within the EVAP system, which is critical for controlling fuel vapor emissions. Understanding the implications of this DTC and its associated symptoms can guide technicians in effectively diagnosing and rectifying issues. It is vital to conduct thorough checks of all related components, including the FTP sensor, vent hoses, and shut valves, to pinpoint the cause accurately. Timely repairs are crucial in not only regulating emissions, but also optimizing vehicle performance and fuel efficiency. Adopting preventive maintenance practices will greatly reduce the likelihood of future DTC occurrences. By remaining proactive, vehicle owners can ensure their Honda Accord operates smoothly and in compliance with environmental standards. Please like and subscribe to the channel. See you next time!